All right. Well, welcome back, everyone. That was quite a talk from JK there with introduction to machine learning and ML.NET. So that's awesome. But with us today now, we have Justin Ormont here from Microsoft. Good morning, Justin.
Hello. As an
It's
intro for myself, data scientist at Microsoft in the AutoML team. I was previously managing data science for ML.NET and the predecessor product called TLC, which was the internal variant of what we have released as a awesome product for .NET developers.
wow, that's great. So you're actually a real data scientist.
So I'm told.
So that's awesome. Well, I know it's early for you there, I think you're in Seattle, right?
Oh, I'm in Silicon Valley. Yeah, it's
Okay.
same time zone um, as Seattle, and it's a very good place for any type of development. There's a lot of fantastic data science meetups in this area to go to. Seattle also has quite a few too. And today I'm very happy to be answering any questions that anyone has. Please post them in the chats. There's a couple different places for it. There's Slack, and there is on Twitch also, and also YouTube if you want to post on there.
Yeah, we have tons of them already, so I won't waste so much time yet. And anyone who wants to have any questions to Justin, just as Justin said, post them and we will try to get to them. But we got quite a few, so we're going to get the conversation going and kind of see where it takes us, right? Um, the first one we have here is, do you think reinforcement learning will ever make it to ML.NET?
I'm not sure if it's reinforcement learning is very good for, say, solving a particular game. Reinforcement learning is very good for a lot of tasks, but MLNet is more focused on what's important for the most common scenarios along machine learning. And reinforcement learning doesn't solve most of those tasks as quickly or sometimes as well as some of the more traditional techniques, um, like just standard classification. Reinforcement learning isn't generally the answer for a lot of the questions being asked in ML.NET. But you can ask um, inside of the repo if you find a use case that's important and there's enough support for it, it'll get built.
Absolutely right. Well, thank you for that. John.
Yeah. Um, Actually, want to do my first question as a question I personally have for you, Justin. How did you get into the data science field in the first place?
Oh, that's a long stories here, but a lot of my graduate work was in machine learning topics. For instance, computer vision topics of how to locate where a cell phone is based on what the camera sees. So, for instance, you could hold up your cell phone and recognize what's across from you. So, recognize the building across the street from you versus, say, a Google Street View image, and use that to geolocate the phone. I was also doing a bunch of other topics within grad school. This was like 10, 15 years ago topic. Um, and then I hopped into Bing as my first full-time job. There's a bunch of ranking work in that area, which is all machine learned ranking, which MLNet does support, by the way, and is the product that was being used then inside of Bing for doing ranking. There's FastTree, which is in MLNet, which is one of the primary things that was used inside Bing for making ranking models. I can go as long into depth here, but we should probably
Well, that's very fascinating. That's interesting. Well,
some other questions here.
yeah, thank you for sharing that with us. We can go to the next question here, which is a more technical one, and that is, how does AutoML find the right algorithm?
Oh, that's a fun topic. So what it's doing right now is it's looking at your data set. It's deciding how to split your data set. So for instance, is it a comma delimited file? Is it tab delimited? It looks at your columns. It tries to decide what the purpose of every column is. So for instance, do I think this is a categorical text column or a free text column, which the last speaker got into slightly. Um, it looks at numeric columns, whether or not it has to fill in missing values. And that goes on towards the model selection part, which is the actual question. So right now it tries the defaults on top of the featurized data set. for every different model of that class. So for instance, if you're doing a regression problem, it tries the defaults on top of the feature vector that it created previously. So that's about 12 model types for regression. It will go through each of those, decide, check how good each does. It will call those to the top 3, and then go on to hyperparameter selection. So it uses a Bayesian optimizer called SMAC, which is a well-known algo. So it does an exploration phase of the hyperparameters, and that goes into the Bayesian phase, where it then uses the knowledge it learned from exploring this multidimensional hyperparameter space to hone in on the areas of the models, which models are best, and which hyperparameters, what areas of the hyperparameter space are best for it to explore. And it selects the one model that did best on the validation data set. Sorry, that was a rather long, in-depth answer.
No, that's very fascinating. I mean, I think that's something. AutoML is something so simple to use, right? But it's fascinating to hear how complicated and complex it is under the surface.
Yeah, and it's all open source. You can go look through exactly what it's doing in the MLNet repo.
Awesome, yeah. And I think just a related question to that as well is, can you apply AutoML to deep learning models?
Oh, certainly. Right now, we're only using it for the image classification part, where we're using a TensorFlow model. Right now, that one is trying for local mode. It's trying, I believe, a ResNet 50 model or a ResNet 101 model. If you're doing the remote scenario, it's using a more advanced recent model, SE ResNext. For the multi-class classification case, the nicety about the remote case is that you don't have to have a GPU locally. So you can spin up an Azure VM that has a strong GPU behind it, and it's then powered by Azure AutoML, which is the same product as AutoML inside of MLNet and developed by the same team. So they're the same products in a different form factor.
Okay, great.
The MLNet one is for the .NET developers to use directly, and through Model Builder you can use the remote mode, which lets you scale out once you get towards bigger data sets. You can handle all your millions of images if you want to run a very large job.
Cool, that's awesome.
Yeah, it's interesting. Let's see, I got one. I think we hit on it a little bit in the workshop yesterday. But what's in the ML.NET model files?
There is your feature engineering techniques in a trained form. So for instance, you did a text classifier. Inside there you have a step for tokenization. You have a step for normalizing the word, so lowercase it, whatnot. And then you have a dictionary of all the words, so you know where to map it from the word cat into slot 5. That information for the feature engineering is stored in the model itself. And then the model, what most people consider a ML model, is the actual final algo in the pipeline. For instance, your trees or your linear model, the weights for that is stored within the model itself. So it's meant to be a little more self-encapsulated of a model than some of the other model storage formats, because it also includes the feature engineering. The only piece that's not inside there to make it fully end-to-end is the data loader. That was a decision that allows users to now export their model more easily. So for instance, you might want a slightly different loader when you run the model than when you train the model. So we no longer store the loader within the model itself. For instance, you could train it on a flat file, but then you run it live from, say, a web service or connected directly to a database. So the loader function is going to look different.
Okay.
You can zip them and look at them. You'll find if you hone in on biggest files in, say, a text classification, you'll see all the words that it has used. You can also look at the weights in there. You can look at how the normalizer gets added, what is actually behind the scenes in your model. It's really quite interesting if you dive into it.
Yeah.
Yeah, I'm going to have to do that.
That's fascinating. Well, another question we have that we'll jump back into non-technical questions here is, what does the life of a Microsoft data scientist look like? What is your day-to-day work, more or less?
That's a very interesting question. Data science topic is very widely defined as different tasks. So in some areas, it's more of a data analysis style. Some it's the ML training. Some it is the people that make ML tools itself. I am closer to making ML tools myself. I focus on making sure that our team is making a useful product for the users. So that's handling some of the benchmarking sides to decide what areas that we need to invest in further, what techniques are useful for us to try, deciding what data sets are representative of our users to be able to test our systems against actual user style data sets. It's a wide topic, and on a given day I'm doing many different things.
Cool. That's fascinating, though. It's good to hear your perspective on that. John, do you want to jump into a technical question?
Actually, I got another non-technical question. Let's see. What do you think about current growth in data science university programs around the world? And do you think they produce quality or just churning out degrees?
Oh, it's fantastic. So people now have a background in AI ethics, like what was being discussed earlier today, which I'm incredibly happy that people are starting to get into. It also gives them a very good background on what target leakage is, which is a problem that a lot of people have, where they, for instance, have an extra copy of a label column and they don't realize why their score is very high. That's a topic we should get further into later. It's a very in-depth, interesting topic.
That's great. Thank you for that. So a more technical question here. Bias is in general a bad thing in data science. But what about if you want to introduce bias by purpose? For example, I know that my feature is 3 times more important than other features. If I don't normalize, it's bad for the rest of the features. If I normalize, I'm losing the intentional bias previously mentioned. How do you deal with that situation?
The models will generally learn around the bias anyway. So if you try and just scale up a single column, it won't make much of a difference. But what you can do instead is find examples within your data set and apply a weight column. What that does is it says this row of data is worth, say, 10 times as much as some other row of data. So for instance, if you have a high label skew where you have a column, you have very few examples of label 1, but you have a lot of examples of label 0. You may want to apply a weight column that makes your label 1 rows worth 10 times as much. And that applies both to the model training steps, the featurization steps, and the metric scoring steps. And that will upweight those specific examples.
Okay. I think we actually have a question similar to that yesterday as well in the workshop, which is good.
Yeah, we did. It was very good questions in the chat yesterday, and hopefully we can keep those going here.
Yeah.
Absolutely. John?
Yeah, so you mentioned leakage. What are some other kind of gotchas that are pretty common when doing training?
Well, one of the most common ones are people, there's a lot of different types of leakages. One of the most common ones are people trying to pre-featurize their data set before they split their data set. So for instance, they'll learn a normalizer before they split their data set. What you always want to do is learn your feature engineering on top of your training set and then apply it to your validation and test set. Otherwise, you're feeding information between the different folds or splits of your data set, and that artificially increases your score. So let's assume that you're trying to guess what the price of something is, and you have a column that has, say, the sales tax on a house. That would be a direct example of a leakage. because you can just multiply out the sales tax to get the label. But there's slightly more insidious forms when you split it that you wouldn't notice, because you can normalize a column and you know what the average of the values are for the training data set. And then for the test data set, you can go back and then calculate based on what was normalized as into the how the test set would have, what the missing values would have been to get that normalization factor, or the model can figure that out. That's a rather weak form of leakage that can be a bit insidious and hide within your training process. AutoML is nice because it will help you avoid all these, because it instills within it best practices. So it will know to learn your feature engineering only on the test data set and apply it to your validation and test data sets, so that your scores are representative of how your model will actually do in production.
That's good. Perfect, thank you. Another question we have here from the chat here is, do you think that GANs and style transfer will make it into MLNet, or should we stick to other deep learning frameworks for those tasks?
Well, what you can do inside of ML.NET is take one of the pre-trained ONNX models and use that as a step within your ML pipeline. So you can take a GAN model from the ONNX model zoo and run it within ML.NET. And then you can launch your model the same as you would with any other MLNet model inside of, say, a web service if you want to host a really cool service and show everyone how to do style transport. It's an elegant way of doing it. For training a GAN model, I'm not certain if it can be done currently. I think the TensorFlow model can learn a GAN model, although I don't know that anyone has explicitly tried it. Please try and send feedback and tell us if it works.
Exactly. Well, I think the question, Gregory asked a question. Let us know if you make it work or not. We'll be interested to hear more about that.
Yeah, and send feedback into the GitHub repo, either the MLNet, github.com/.net/machine learning, or the machine learning -model builder for the model builder specific topics.
Absolutely. All right, John.
So question here, what compelling reasons do you see for data scientists to choose .NET or ML.NET specifically over like scikit-learn and Python or something similar?
Oh, that's a really good question. So one of the primary determinators is whether you're under Python or .NET. .NET developers, ML.NET is the best answer for .NET developers. There's a lot of advantages to ML.NET over scikit itself. For instance, speed, memory utilization. It can handle very, very large data sets. I've run terabytes of data through it. This has been hammered on inside of Microsoft for more than a decade at this point. It is a rather battle-hardened product, which is why we put out a pretty strong release long before the 1.0, because this was a decade in production beforehand. So it's calling it a 0 point was mostly pulling punches until we normalized the API surface. We didn't want to call it a 1.0 product. It wasn't because the underlying code was unstable or not good. It's just to stabilize the view of the code.
All right, awesome.
Scikit is nice. It has a very good Python interface. So if you're primarily in Python, you may want to prefer Scikit. But there is Nimbus ML, which is ML.NET for Scikit, that offers a Scikit interface. So you can switch from Scikit directly into Nimbus ML, which is then backed by ML.NET. And it's a couple line code change from your Scikit product.
Interesting. I didn't know about that. Thank you. Another question we have in the chat here is, do you often see decision makers come to you to ask specific questions about available data and disregard your insights if they don't like the answers?
About available data. Normally, like the data that they have available, I'm not quite certain on what the question is in this case.
Yeah, we can move on to another question. And Gregory, if you want to clarify that question, please do so in the chat, that we can ask it a bit later as well. I think I'm going to ask Praveen's question instead here in the place of that. A DNN model's validation accuracy is one aspect of validating it, There are other ways to validate it, such as grad cam, that allows to visually check where model is looking. When shall we see such features in ML.NET?
So model explainability is a very important topic. Within MLNet right now, we have PFI, which I believe Bree touched on slightly yesterday, along with the feature contribution calculator. If I recall, the one that you mentioned is a image explainability that is a local image explainability that will tell you about why it's selected a specific class for a given example. That's closer to the FCC model, FCC algo that we have in ML.NET. Specifically for images, we don't have a explainability hooked up to it currently. We will do that for the remote case. I expect that to come out first. I don't know if we currently have a plan for the local explainability for images. We haven't gotten too far into that topic yet. The remote case, though, the explainability for images then would run through an Azure service that is probably going to come out first, although we don't have a timeline for this so far, and that work has yet to be scheduled.
Okay.
But it's an important topic. You should know that your models are choosing the class, even if it chooses the right class. You want to know that's choosing it for the right reasons.
Absolutely, yeah, definitely important. And I think I guess I feel like we hear more and more about that every day, about how important that is.
Definitely.
John, do you want to ask the next question?
Yes, let's see. Here's an interesting one, especially since we just had a talk about model builder. How long should I train for model builder or in the CLI?
Another great question, and it's a hard one to answer. So one thing that you can do is run for a short time once. So try 30 seconds, try 10 minutes first, depending on the size of your data set, and see how long it takes to make a model. What's going to try first, for at least the multi-class classification case, is average perceptron that is often the winner. That's a linear model that tends to be faster, but you can use that as a basis for how long you should train. You want to aim for about 150 models total, which gives a Bayesian optimizer time to locate a good position in the hyperparameter space. Because what it does is first the random exploration of the space and then drops into the Bayesian step around model about 70. And then from 70 to about 120 is when you get most of your final gain. So it starts to plateau at that point. So about 150 models seems to be the optimal point. So you can see in the output how many models that it tried inside Model Builder. In general, more time is better. But you can, of course, just make one model, and maybe that will be good enough for you, depending on your use cases. Plus, it will toss out the code for you also, and you can dive directly into the MLNet portions from there.
Yeah, which is very nice. It's a good seed, I think, for future development and exploration. So a question we have in the chat here, Justin, I think that you may have seen as well before, is that Scombra asked, is it really a split of 50-50, not 70-30 or 80-20? And I think referring to the AutoML split, I think.
AutoML right now, by default, chooses an 80-20 split, although it automatically goes between cross-validation and train test depending on the size of your data set. Right now, I believe we have the cutoff around 15,000 rows of data, at which point the train test is less than... The train test gives you an accurate enough score. Right now, for small data sets, cross-validation is important to run because it reduces the error bars on your metrics such that you can have confidence in the metrics that it's producing. If you have too small of a data set for a train test mode, you can be dominated by noise instead of what the actual metric value is. Cross-validation gives you both the error bars and it gives you confidence in that you're reducing the error bars by repeatedly doing the cross-validation step and trying different folds of the data and averaging across.
So would you say that cross-validation is recommended to use even for larger data sets?
It depends. The value goes down as the size of the data set goes up. But what it can always give you is a confidence on top of your data set. Producing, say, a 95th percentile confidence interval gives you error bars on top of your on top of your metric. So you know that in production your model will perform within this bounds. A train test score doesn't give you that. It just gives you a score. You don't know how much that score is expected to vary.
Mm-hmm. Do you get those metrics as well from the metric, I guess, output from cross-validation? I don't think I've actually inspected it too much.
You would have to run inside of the API, and you'll have to then push the scores into. There's a class in MLNet. I think of what it's called. That is a cross-validation metric score that calculates confidence intervals for you. You can place your metrics. You can push every metric returned into that object, and it will tell you the confidence scores back.
That's great. I have to check that out myself. All right, John, do you want to post another one?
Yeah. I'm actually curious about this now that I saw it asked. How is Azure AutoML related to AutoML and ML.NET? Because I think those are two different products, right?
They're in essence a singular product for the AutoML side, developed by the same team. The MLNet AutoML was coded by people in the AutoML team to be another variant of what is run in the remote scenario, except it runs, of course, locally to your one machine and is in .NET also. The Azure AutoML is how you'll scale up your project. So you want to run locally, and then it allows you to move to the cloud, and that offers all kinds of extra advantages. Some of them are more related to corporate usages. So for instance, it offers lifetime track of the model, who trained it, when did they train it, what was it trained on, some of the important pieces that corporations very much need to track. It will also offer ability to retrain a model easily, data drift detection, offers explainability, those kind of topics that aren't available locally at this point.
Oh, that's interesting.
Perfect. Yeah, thanks. Another question in the chat here is, are there any good code example of transfer learning with ML.NET? Want to take a pre-trained open source model and do transfer learning on it with MLNet?
That's another fine question. So right now, that's already done for you automatically in some cases. For instance, in the image model, that's using a pre-trained model learned on ImageNet. It's a very large data set that's well known across the ML industry. And for images, it learns how to recognize 1,000 ImageNet classes, like different types of cats, dogs, cars, whatnot, and then uses that to fine-tune. That model is then used to fine-tune a model specifically for your data set. Another example with an MLNet is a word embedding that's available. So that's learned on a large text corpus, where it has learned what different words mean, and it doesn't have to relearn it for your particular case. If you want to do that yourself, you can also import a custom word embedding model. And for the image case, you can use Onyx as to run your custom image model and use that as a featurizer. You could also use it to refit to your new data set if you want to refit instead use as a featurizer. There's a couple more examples, but we should probably.
That's great.
Yeah. So I got one from Zal. Which ML model should I use for something like autocorrect or spell checking? And would you need a custom model for Unicode-based language?
That's a hard question. It depends on how you want to pose that to as a machine learning task. I have not built a spell correction model myself. Perhaps you could pose that as either a ranking problem might be the most sufficient. I was thinking multi-class would be an interesting way to go, but a ranking class would be a lot more scalable. Multi-class won't scale to the number of words. So you're going to have issues with that. You'll end up with an enormous model, and it'll take a long time to train if you do it as multi-class. Another route is as a binary classification of misspellings on the left and the correct spelling, correct or incorrect correction on the right. That may also do well. Your feature engineering techniques are going to become even more interesting there. The default tri-charactergram may do quite well on that.
Interesting. That's a great answer.
Some custom featureization in there also. It'll be very, post the question in the repo. I'll answer over there and we'll see if we can find a good answer for you.
Yeah. Oh, awesome. Yeah, so I'll definitely post that in the repo. I would love to follow that discussion as well. All right, we have another question here, and this one is, how do you see AutoML and data scientists working together?
The nice part about AutoML is that it can take a lot of the workload off of data scientists. So a lot of the work in data science is the iterative process of trying a bunch of different feature engineering techniques, analyzing the data set, trying to try different models, different hyperparameters in the model, and they can accelerate that process extremely quickly. So for instance, in one of the previous talks, you saw the enabling and disabling of different columns. Behind the scenes was still the sweeping process that AutoML does. So it was accelerating the process that we saw before by just allowing the data scientists there to easily add and remove the columns and see the effect of it, including the sweeping process that AutoML does. It also allows a data scientist to learn novel techniques, what works well on their data set. So you can just toss AutoML at and see, well, this gets me extremely close to a good model. Now I can use that as a kickoff point to make an even better model by hand optimizing it after AutoML outputs the direct source code for making that model.
Great, thank you.
Yeah. And speaking of some feature engineering, what type of feature engineering will be like most useful in ML.NET? I know we saw some dropping of columns, but are there any other techniques that we can use?
Well, for basic types, AutoML will output the code that is suitable for your data set. Right now, what it uses is mainly n-grams. That defaults to bigrams and tri-charactergrams. For categorical columns, you can use standard one-hot encoding. For numerics, you normally want to normalize that. And there's not much that you have to do with most numbers besides fill in missing values. For categoricals, there's a bunch of interesting techniques to try. There's one that used to be called Dracula within our repo that does counting, which is why it was called Dracula. I decided to rename it to something a little different. I believe it's called target encoder because it's a form of target encoding. There's really advanced techniques that you can try within MLNet beyond just the basics for yours. So one really fun thing that you can try and is quite useful is training a k-means model on your numeric data and using that as a stacked model within a bigger pipeline. So what that does is it learns to cluster your space of numbers here and uses the output distance from the centroids of every one of those clusters as a new feature into your final model. There is so many very interesting ones. There's one called tree featureizer, which is another form of a stacked model. So you're learning a tree for all your data, and then you're using what leaf node the current row landed in as a new feature. So you have, say, 100 trees. You're going to have 101 ones inside of your output vector from the tree featureizer, plus a bunch of zeros that current example didn't land in. What that allows you to do is learn a subset, a tree on a subset of your data in a very, that allows it to learn the interaction between the different features using a tree. And then you can scale up into multi-terabytes of data by feeding that tree that was trained on, say, 10 gigs of data. And then you can stream through that tree into a linear model that can relearn the output weights on the tree. And then you can run multiple terabytes of data through that model, which wouldn't otherwise be doable with the tree itself.
Great, thank you. Kind of following along the same lines a little bit here, how can I handle text in MLNet?
Well, there's a few ways of handling text. The most common way is running it through the text the text featurizer, and that does a bunch of sub-steps behind the scenes. For instance, it will tokenize for you. It will remove diacritics, which are like accent characters that you see on top of, like the accent characters on top of, say, Spanish text. It will remove that and normalize the text. It will, by default, lowercase for you. You can also use it, have it remove stop words for you. And then it will create, by default, bigrams, which are pairs of 2 words next to each other, and tri-charactergrams, which are a sliding window of 3 characters in a row. The 3 characters in a row method helps you a lot for out of vocabulary issues. So for instance, let's say in your test data set, there is the word running, but in your training data set was only the word runner. If you used only n-grams, you would only know about the concept of running or runner, and if your test data set had running, it wouldn't have any basis of that. But the tri-charactergrams would extract the RUN portion of that and learn a weight for the RUN as a concept of a person moving quickly, as opposed to having to individually learn the words. There's also the word embeddings within ML.NET that is, like we mentioned before, a method of transfer learning where you have this big corpus of information that was used to learn what every word means. There's also an external project that was kind of interesting I saw, that someone made a BERT model for ML.NET. That's an interesting one to look at also. That is going to be incredibly slower, but BERT is what is taking over the world, the different transformer models. That's something that we should consider pushing into ML.NET proper. Right now there's an external project of someone demonstrating how to do it, which is super cool that we get external people doing really impactful things like this. These are things that should be contributed back into the main repo. They're fantastic.
Awesome. I think, John, do you want to ask a question that's kind of following along the same lines there?
Actually, you just answered it. If we can use BERT within ML.NET.
Yeah. Someone made a fantastic example of how to do it.
Yeah. What's the repo address, or like who's the user?
Oh, let me go look up quick.
I think we can put that in the chat real quick for anyone who's curious.
And I guess while you do that, are there any other?
Just look up BERT-MLNet.
I will do that, and BERT-MLNet. Okay, and then I will put that in the chat.
Yeah, it's so cool that somebody built that. The hardest part on there is actually building the tokenizer, because BERT uses a really interesting, novel tokenizer that does sub-token matching when it doesn't know the word. It's novel in its interest, and the code for that is a little more complex than our current tokenizer in ML.NET.
Awesome. Let's see. We'll find it later, and maybe you can put it in the chat after your session as well, Justin. Oh, we got it. Thank you, Luis, I think. Awesome. Hayan Vlot. All right, perfect. So a question I have personally as well is, do you have any suggestions or recommendations for, let's say, .NET developers out there that have been developing software engineers for their whole career and then want to transition more into the machine learning space here and are fascinated by MLNet and wants to start using it? What are some things I need to do and think about to get there?
Oh, certainly. There's a lot of people transitioning that route. Like, I expect machine learning is one of the core things that get taught in comp sci these days. Back when I was doing these courses darn near 20 years ago, it wasn't a primary focus of the comp sci world. It certainly was around, but it was less upfront than it is these days. What you should do in ML.NET is just start playing with it, start using it, start running through some of the examples. Pull open Model Builder, run it through a dataset, run on Kaggle, see how you do. With MLNet, with the CLI and with Model Builder, it will make the full training pipeline for you in code, so you don't actually have to know the data science behind machine learning. You don't have to even know what to try. It will make a full pipeline for you, and then you can use that as a learning stepstone into machine learning by seeing what it produced for your data set. And then you can work back on why it shows that type of feature engineering, why it chose that type of model, and use that to learn machine learning itself. One other thing about BERT is as Model Builder adds remote classification for non-images, Azure AutoML does use BERT in the background. So that will become alive for the remote scenario as soon as Model Builder adds connectivity for training on standard tabular data sets instead of strictly the image classification. So you can then do text classification within Model Builder through the Azure remote mode, which currently has, Azure AutoML has BERT's backing it, because it does extraordinarily well. It is what the state of the art is currently.
Fascinating. Yeah, great. Thank you for the answer.
Let's see.
We just got another one here from Jeremy. Do you want to ask that one, John?
Let me find it. All right. Is there a good resource for learning simple data science that help us clean up data based on the scenario that we're targeting, such as product recommendation or binary classification?
Is this more focused on the data cleansing part, or just how to set up a start making a model itself?
I think the data cleansing parts.
Oh, that's a really deep topic of how to best clean data. A lot of it you may find is it's important to have clean data, but you should just test if it works first. Sometimes really dirty data, you can still make an extraordinarily good model on top of. Machine learning is meant to be robust to this, and over the last decade, we've made MLNet rather robust to having dirty data be fed in, because around Microsoft, people, of course, clean up their data, but some people don't. So we need our models to be optimized for both scenarios. But generally, just open your data set, look for the columns you want to see that everything is aligned properly. So some of the big things that can go wrong is, so some data sets you will have a misalignment. So when you export it, you had, let's say you're pulling together multiple files. A lot of cases I've seen is misalignment in the data sets. So one span of the data set had 10 columns, another one had 11, and it just directly got joined together and concatenated. You'll see examples like that in the wild, like the New York taxi data set is wildly shifting around in the number of columns if you directly append the different types of the New York taxi data set. There's all kinds of data quality issues that you always run into, and upfront you have to spend a lot of time just ensuring that it is correct. But if it's reasonably correct, just toss the ML at it and see how well it does. If it doesn't meet your expectations, go back, fix things. Data science is an iterative process, and data is always dirty. That's the nature of it.
Awesome, thank you.
I've actually noticed ML.NET is they can handle when you feed in missing data. If I do the same thing and scikit-learn, it's just going to yell at me. So.
I had a similar experience actually when I started with ML.NET, and I had the same data on scikit-learn and MLNet with just the defaults. And scikit-learn threw out of memory exceptions and never got me anything. And MLNet was done in 20 seconds and with a really good model.
Yeah, we have a whole paper on the topic from, I believe, KDD last year, showing how MLNet scales better than scikit. And that's because internally in Microsoft, we had to. Big data sets are the norm inside of Microsoft. People aren't coming generally with the 100 rows of data. They're like, oh, here's 10 gigs, here's 100 gigs. Oh, I want to run a couple terabytes through. We're like, okay, head.
All right.
On both the high end and the low end because it's quite varied in the use cases. And we've spent a lot of time optimizing defaults and choosing, say, defaults on what the text classifier, the text transform will do, what the defaults are in the models. We spent a lot of time optimizing so your first run is good. This is how the AutoML that backs it is also good. It's standing on the shoulder of giants.
Awesome. We'll get some questions coming in right now here. So A user says, heard about turning NLG. Can that model be used in any way with ML.NET? Turing.
I'm not aware of that model. I'm sorry.
Okay, that's fine. We can ask another question here. How are dates and numbers treated in ML.NET? How does it know what the date is?
So there's a datetime type within ML.NET. So you can use that as your import. So in your input class, you can have a type of datetime. And then what you do with it after that is you feed it to the time date transform. That was added, last few months. Previously, we didn't have any external way of handling dates besides the custom mapper. But what that does is it produces the time of the day of the week, the day of the year, the month, the date, and splits up and featurizes dates and times. It's very proficient, especially for time series forecasting is one of the more important areas for that. There's also some gotchas in the territory. For instance, you don't want your model to learn that last year the value is high, because then your model won't generalize to next year. It will learn that in 2019 that more oranges were sold than 2018, and not necessarily be able to generalize. So it can be useful to not include, say, the largest time value within there. Something to try. Try and remove it, see if you get better on your test data set. Also, it's important to split up your time series data sets on time and have the newest in your test set and the oldest in your training set, and the middle part for a validation data set. It goes back to the topic of leakage. There's a fine Wikipedia article on machine learning leakage. It's a good thing to read through. I use Wikipedia as my scratch pad for ideas. So look up my commits on Wikipedia, and you'll see a bunch of machine learning topics I'm interested in.
Great. John, did you ask? I think we can have a last question actually right now before we have to hit the next topic.
All right. Let's see. How does AutoML handle outliers and missing values?
So the outliers are handled pretty nicely by trees, and also in your test data set, the outliers will affect the linear models pretty much, but the trees are very robust to it. So the AutoML will hone in on the trees that are more robust to it by running through the test set and measuring the difference between the expected score and the actual score based on the test data set and the metrics that produces. It will hone in on the models which are more robust to outliers, so it will generally avoid linear models and go, like I mentioned, more towards trees. For missing values, it automatically AutoML will fill in with the NA handle transform, which will, for numerics, I believe it auto-fills with a 0, which works well for both linear cases and for trees. Another thing that you could do manually is before the data comes, you can add prefeaturizers. If you're using the AutoML API, you can add prefeaturizers to custom handle it. So for instance, if you want to prefill your values with, say, the average value, you can append that as part of the API call, where you tell it the transforms that you want to be run before AutoML appends its own featurizers. Another piece that is in AutoML is it does, along with the imputing, it also does an indicator column to say, hey, this value was missing, which can be important of its own.
Awesome. Well, Justin, thank you very much for answering all those questions. That was a lot of questions in 15 minutes.
Yeah. Any more questions, feel free to post in chat. Feel free to drop on our MLNet repo and try out the remote scenario of Model Builder.
Yeah, absolutely. That sounds great. Thank you, Justin. And what we have coming up right now is actually an interview with Michael Gerfen, who is using ML.NET within his organization. So definitely stay tuned for that. And on the full hour, in just 10 minutes, we're going to have Luis Beltran presenting on transfer learning for deep learning from custom vision to TensorFlow and ML.NET. So that'll be a very interesting and fun talk to listen to. So definitely stay in tune for that in 10 minutes. But for now, thank you so much, Justin.
Very, very happy to assist people here. Thank you so much for letting me.
Thank you, and enjoy the interview.
Thanks. Bye.
Mike, thanks for agreeing to do this interview with us. If you don't mind, can you just do kind of a quick introduction to yourself and what you do?
Sure. Yeah, my name is Michael Garfin. I'm the founder and executive partner for Evolution Software Design. We were founded in 1995, so we've been around for a while. Real small, kind of boutique software shop, but we have some fairly large customers.